What's up, everybody? Welcome back to Vibe Code Camp. I'm Paul Wakeham, and in this video, I'm going to go over some pretty serious updates that we've made since the last video. What we implemented this time is an agentic system. Instead of just one AI, we have multiple AIs that we're sending messages to. But let me recap real quick what we built and why. So first, if you remember from last video, we have the user's message going to our application here. Right now it's just the back end, and then the user's message from the back end is sent over to OpenAI. Now, in the last video, the AI agent was calling all of the tools directly using Composio. So we defined tools that allowed the AI agent to interact with our user's calendar with authentication handled by Composio, and call the Google Maps API, again handled by Composio. But as things get more and more complex and multiple calls to multiple tools need to be made, this single AI system, it usually doesn't work as well as if we had this AI talking to other AIs that then went out and interacted with these tools. So if you remember from one of the first or second videos we created a while back, the tool that we're going to use to create these multiple agents that interact with each other is called the OpenAI Agents SDK. And the OpenAI Agents SDK allows us to define this type of system here, where we have the user's message coming to the application, and then the user's message going to an orchestrator agent, which is the hub. The user's message is sent to the orchestrator agent, and then the orchestrator agent orchestrates, you can think of it like a orchestra director, orchestrates all these other agents. And these other agents, like the calendar reader, calendar writer, and the maps agent, they then through Composio have access to the user's Google Calendar and the Google Maps API to do the thing that they were instructed to do by the orchestrator agent. So what's different about this system, and what's really interesting about these multi-agent systems, is we as the user, or any user of this application, they never interact directly with any of these sub-agents. We interact directly with the orchestrator. The orchestrator takes our garbled sentence of what we want to do to our calendar and where we need to travel to and where the appointment one is and what the next appointment is and all of that. We just dump all of that information to this orchestrator agent, and then the orchestrator agent interprets all of that into prompts, messages to the calendar reader, calendar writer, and maps agents that then do things on the orchestrator's behalf with their tools through Composio, and then report back to the orchestrator agent. Then the orchestrator agent says, okay, great, the changes were made, or I have information, I'll report back to the user. Or the orchestrator says, no, I need to call on these agents again. So let me give you an example that we're going to actually go over in the code. So on my calendar, I have this appointment tomorrow, Monday, October 13th at 2:30 p.m. until 3:30 p.m. to meet with my friend Kevin to talk about AI automation at Whole Foods on First Avenue in Denver, Colorado. Okay, great. So whenever I say to the agentic system, which I'll show you how we did this in code, whenever I say to the agentic system, hey, I need to meet my friends for dinner after this meeting at this restaurant called The Brutal Poodle in downtown Denver, the AI will know, the orchestrator will know, okay, I need to figure out where that appointment is on Paul's calendar at 2:30 p.m. Where is that Whole Foods? Then this calendar reader will interact with Composio. It'll get the calendar appointment and the location. It will send all of that back to the calendar reader. The calendar reader will send that back to the orchestrator, and the orchestrator will say, okay, I now know there's an appointment at 2:30 until 3:30. I know that it's at Whole Foods. Not exactly sure why I'm meeting at Whole Foods with my friend Kevin to talk about AI automation, but maybe that's the right place to meet. Then the orchestrator will take that address and it will send it along with the name, The Brutal Poodle, where I'm meeting my friends for dinner. It'll send that address along with the Brutal Poodle to the Maps agent. The Maps agent will say, okay, I need to figure out where in the world is this place called the Brutal Poodle, and I need to figure out how far that is from the Whole Foods so that when Paul needs to schedule this appointment after the Whole Foods meeting, how much time does he need to travel and what time can he schedule that appointment at? That will all be done through Composio and the Google Maps API. That will be sent back to the Maps agent. Then the Maps agent will send all of that information back to the Orchestrator agent. Usually what will happen next is the Orchestrator agent says, okay, great, it's going to be X number of minutes to drive from Whole Foods to the Brutal Poodle. Your appointment at Whole Foods ends at 3:30. Let's get you to the Brutal Poodle by whatever time. Do you agree with this? And I'll say yes or no. And then if I say yes, the Orchestrator agent will say, okay, I understand the task now. Let's update the calendar. And it will call the calendar writer agent. The calendar writer agent will then use its calendar tool to put an appointment on my calendar at the Brutal Poodle with the correct space between the Whole Foods appointment that ends at 3:30 and the next appointment at the Brutal Poodle. So this diversification of responsibilities, or this like spreading of responsibilities, is in a lot of ways very similar to the sub agents that we set up inside of Claude Code. So ideally, that's how this system works. Like I said, it was a lot of debugging to get to this point and a lot of bug squashing to get to this point. And I think that it's going to work. I'll do a live demo here. But let me explain real quick why it was so difficult to get this system working and why it may be difficult for you to get this system working. So whenever you write code, let's say you wrote a piece of code that says 2 plus 2 and it returns the number 4. That is what's known as deterministic code. If you put 2 plus 2 into this code, the number 4 is always going to come out. It's always going to be the same answer every single time. That's a very simple example, but traditional code that doesn't have anything to do with AIs and traditional systems that don't have anything to do with AIs, unless they're broken or have bugs, if you send X in, Y will come out every single time. If you send X in, you're never going to get B or C or Z out. You're always going to get Y out. That's called deterministic code. Now, AIs, the way that they work is what's called probabilistic, meaning the probability of, I think I've said this in past videos, the probability of the next word that the AI sends in its message is calculated. So if you send in X, sometimes Z will come out instead of Y. Why am I telling you all of this? I'm telling you all of this because the way that these AI agents here are defined is not with is not with deterministic code. It is with probabilistic natural language instructions. We literally say in natural language how this orchestrator agent is supposed to work, how it's supposed to respond to the user. We could tell it respond like a pirate, and it would most of the time, almost all of the time, respond with an R as its response every single time. And that makes it difficult to make sure that the inputs and the outputs are identical each time. So it was a lot of prompt tweaking and fine tuning of the personalities and the capabilities of all of these agents to get it working. When the user says, I have an appointment at 2:30 at Whole Foods, help me figure out what time I need to get to the Brutal Poodle to have dinner with my friends. Sometimes, because it's all defined in just natural language, not code, it's a probabilistic system, not a deterministic system. Sometimes the AI would come back and say something that doesn't make any sense, and it's just because my prompts needed to be tweaked. The definitions that make up the personality and the capabilities of this AI agent, the orchestrator, and these other sub-agents, they needed to be tweaked. So I hope that makes sense. Let me jump into the demo of what we've created. Okay, so here we are in Cursor, and you can see that I have this command loaded up in my terminal. The yellow node here, this is Claude Code, and then here I have this command ready to send. And this command is python manage.py chat_agent, and then the user ID. This is what's called a management command, and it's specific to Django. It's a way of us running files of code. So there's a file on my computer inside this project called Chat Agent. To get here, I asked the AI to fix everything and make everything work, and then make this chat agent file as a management command that I can run to test the conversation back and forth and the capabilities of the agentic system that we just went over. So it created this management command that we can send, and it has this parameter here, or this argument, that is -- user ID and then test user 1. That -- is just an argument. It's a way of passing information, passing variables that could change into the chat agent function, or the chat agent management command. So let's see if it works. Remember, on my calendar, there is the appointment already between 2:30 and 3:30 p.m. at the Whole Foods in Denver, Colorado, to meet with my friend Kevin. So let's run the command, and then I'm going to say, I need to meet my friends at the restaurant called The Brutal Poodle on Broadway in Denver, Colorado, after my 2:30 p.m. appointment. Can you help me schedule that? Okay, now I have this message. I'm going to send it. Fingers crossed, the AI is going to get it right. So we're going to see some logging statements here of different calls made to OpenAI. Then the agents will talk to each other. We can see these various things talking to each other. It says it's called the tool get calendar events list. And it says, it looks like you don't have an appointment scheduled today at 2:30 p.m. Would you like to schedule a meeting at the Brutal Poodle at a specific time instead? I forgot to say tomorrow. The appointment that's at 2:30 p.m. is on my calendar for tomorrow. I need to meet my friends at the Brutal Poodle tomorrow after my appointment at 2:30 p.m. So that was good. It realized that I didn't have any appointments on my calendar today at 2:30 p.m. It's saying that it can't find my appointment. Let's check and see. What appointments do I have on my calendar tomorrow? Okay, so it did say that it found the appointment. So the AI must have not called the correct tool, but from that single prompt, you're seeing it all happen live. From that single prompt that I said, what appointments do I have on my calendar tomorrow? The AI passed messages back and forth between that agentic system, and it found, oh, I do have the appointment on my calendar tomorrow. And it said, your AI automation meeting with Kevin ends at 3:30 p.m. and it will take about 15 minutes to drive to the Brutal Poodle. I can schedule your meeting with friends around 3:45 p.m. Would you like me to do that? So it, for some reason, didn't look to see what appointments were on my calendar already until I asked it to see what appointments were on my calendar already. So this is exactly what I was talking about. The debugging, the updating. Now I have to go back into the Orchestrator and the other Google Maps, the Google Calendar reader agent, and tweak those prompts to make sure that it always checks the user's calendar, my calendar in that case, for existing appointments. So it didn't know to do that automatically until I said, what appointments do I have on my calendar? And then it had the aha moment here in all of these different calls. Oh, there is an appointment at 2:30, and then it ran the Google Maps agent. You can see get Google Maps directions executed successfully for test user 1, and it got the drive time. Let's confirm the drive time before I tell it to schedule this appointment. Awesome. So despite that slight hiccup, the drive time is correct. So if I had an appointment tomorrow at Whole Foods on First Avenue in Denver, which is where the appointment is at on my calendar, and I wanted to be at the Brutal Poodle as quick as possible thereafter, I believe the AI suggested that it takes me about 15 minutes to drive to the Brutal Poodle. So perfect. Now let's confirm that if I say yes here, it will send that message to the Orchestrator agent, and the Orchestrator agent will come back and it will say, okay, now I'm going to call the calendar writer agent and it should update my calendar. Let's test this. Yes, please add it to my calendar. I need to be there for 2 hours with my friends. Okay. Moment of truth. It says, your meeting with friends at the Brutal Poodle is scheduled for tomorrow from 3:45 p.m. to 5:45 p.m. Enjoy your time there. If you need anything else, just let me know. How nice. Let's hope that it got it right. Fantastic. It actually worked. Wow. So much debugging, so much back and forth, and it actually worked. So we have the Whole Foods meeting on First Avenue, a 15-minute gap for travel time that the orchestrator agent used the various agents to find, and now we have the appointment scheduled. Meet with friends at the Brutal Poodle. Fantastic. Okay, so now let me explain all of the different processes that we went through to get here and show you how I structure all of my files to define the agents to do this. So let's jump back over here into Cursor, and you can see that I have a lot of documentation here. Before I go into exactly how all of the AI agents are defined, I want to make sure that I point out this system, this process that I follow. So every single time I complete a phase or I do something significant, I have a whole conversation with Claude Code over here. As a part of my workflow, I always tell Claude Code, hey, I need you to write documentation about what we just found. So we can see here I have the phase 5 complete summary, and it is 350 lines long, 345 lines long, and then I have the completion fixes. So these are some significant fixes that I had to go through over the past couple days because I was testing and it wasn't working. As I was figuring out with Claude Code what was and was not working, and I was copying and pasting messages like this back and forth to Claude Code saying, hey, it wasn't scheduled at the right time, or it wasn't scheduled on the right day, or it didn't show up on my calendar at all. Claude Code would figure out what the problem was, and then I would tell it to write documentation about that. That way, as I started a new conversation with Claude Code, I could pass it all of this documentation and say, hey, don't make the same mistake again. Here are the answers to the problems that we had in the past. Read this, understand the plan, and understand what we've done so far as a way to start the next conversation so that you're always building on the knowledge that Claude Code has about the thing that you're working on, not going backwards trying to figure out how to fix bad code with even worse code, and that just compounds on top of each other. So just writing this documentation and making sure the documentation is written correctly after a major breakthrough was had, something successful happens, or a major bug comes up so that we can define it and fix it. The other thing that I want to point out is this video summaries section here. So if I go and I open up a new instance of Claude Code, I want to show you this command that I created. So this is called a slash command. If I have a new chat with nothing else typed and I just type slash, you can see this video summary comes up. So that video summary takes everything that I've already said in the conversation with Claude Code, and it writes this markdown file. And I created that as I was going through this process over the last week and a half to get this working. I created these video summaries so that there were very distinct things for me to talk about in this video. And I want to show you not so much the outcome of those video summaries, because that's what this video is, but I want to show you how these commands are defined. So in our .claude folder, we have our agents folder, our agents directory, and we have our research specialist agent. But at the same level as the agents folder, we have this commands folder. And inside the commands folder, we have this about 100 lines of markdown text that is effectively a prompt that is sent to Claude Code every time I type /video-summary. And it's just a way of, without having to repeat this same command or this same prompt every single time, I can save that prompt or save that command inside of this slash command. And inside of this slash command, it says review everything that has been done and then write a markdown file in the video summaries directory. And that's just so that I can keep track of all the things that I want to talk on this video about. Okay, now that we've gone through all the documentation, let me show you what we've created. So inside the backend folder, let me close this. Inside the backend folder, we have this scheduler. This is our Django app called Scheduler. And then inside of there, we have our agents. And we have first, let's go to the Orchestrator agent. You can see that the Orchestrator agent is primarily this orange text here. This is the probabilistic code that I was talking about before. The orchestrator agent, the bulk of how it is defined isn't so much all of this code up here, but it's all of this just prompting that we've done. So as we define these agents, they are defined in natural language. None of this is code. This is just natural language. We can see here we have parallel delegation. You can invoke multiple specialists simultaneously. When to use the calendar reader. User asks, what's on my calendar? Need to check existing events before scheduling. When to use the calendar writer. So instead of writing the code that says, this is exactly when you use the calendar reader or calendar writer, or how to do parallel delegation, we do all of that in text and then hope that the way that we've described it is absorbed and understood well enough by the brain behind the scenes inside of the AI to understand this and know what to do with it. And the same exact thing is true for the Maps agent. All of this code here is defining the tools that it has access to, like reaching out to Composio and using the Google Maps API through Composio, but a lot of this file is the instructions. Same thing for the calendar reader and the calendar writer. These are just tools. All this code up here is just tools that allow the calendar writer to make changes to the Google Calendar. And then a lot of it is just this prompt here. Same thing for the calendar reader. I won't repeat myself again. But something I do want to point out here is this little bit of code down here is specific, or unique, I should say, to the OpenAI Agents SDK. So all of the code that runs behind the scenes whenever we install the OpenAI Agents SDK, it says when the user puts this inside of their file, the agent is called calendar writer. The instructions are defined by the function get calendar writer instructions. And the tools are defined by this array list, this comma separated list, which is called an array, of all the tools that it has access to. So the tools that we've defined in code above are the create calendar event, update calendar event, and delete calendar event. If we click on this, we can see where else the code says delete calendar event, and we can see where that tool is defined. So I told Claude Code I wanted to create a tool that the calendar writer agent can call that is defined in the calendar writer agent's instructions and code here, and up here in its instructions it says here your tools are delete calendar event, and it wrote this code that interacts with Composio, and you can see here composio.delete event. So what's happening is we have this file here that represents the totality of the calendar writer, and we give it its name, its instructions, and the tools that it has access to, and the model that it is supposed to use behind the scenes to make up the total agent. And each of those tools uses Composio to interact with the various APIs, like the user's Google Calendar. So this is how agents are defined inside of the OpenAI Agents SDK. Okay, next, for the OpenAI Agents SDK, you have to have this file called context.py. And the context is, you can think of it like a scratch pad that all of the agents have access to, or a notepad that all of the agents have access to. And in this case, what this context passes is the user's ID and the time zone that the user is located in. And we can see there's actually an issue here where it's assuming that the time zone is America/Los Angeles, not America/Denver or Mountain Time. So maybe that's the source of some of the problems that I had with appointments being scheduled at the wrong time. Anyway, I can go back and fix that. But this context you can think of as like anything that's passed into the context. The OpenAI Agents SDK handles giving that to the orchestrator, the calendar reader, the calendar writer, and the Maps agent so that they're all on the same page and they all have the same base information. Otherwise, we'd have to figure out how to pass each time we interact with one of the agents, hey, this is user number 1 and they're located in the Denver, US time zone. So again, it's that scratch pad It's something that is defined by the OpenAI Agents SDK. Now, here inside the Composio folder, there are all of these calendar, client, executor, maps. These are all files that were written automatically by Claude Code in accordance with the documentation from Composio to interact with all of the different calendar and maps APIs. This, to be completely honest with you, I don't understand most of the code inside of here, but I know that it is used by the tools that are defined inside of each of the agents to allow each of the agents to interact with the tools that they need to interact with. Okay, next, what I want to explain is this data folder here. Now, this data folder here, it's not really long for this world because the next couple videos we're going to go over setting up our database. But one of the problems that I had whenever I was writing the code so that I could have this back and forth conversation that I showed you a couple minutes ago, one of the problems that I had was that the AI wouldn't remember what was previously said. So I would say, what's on my calendar? And it would say, here's what's on your calendar. And then I would say, okay, create a new appointment after the appointment at 2:30. And it would say, I have no idea what you're talking about because it wasn't saving anything. So what Claude Code suggested we did was set up what's called a SQLite database. It's a very fast database that runs on my computer that for this demonstration, for this step in the project, is just saving the user's messages so that each time we pass a message or send a message to the Orchestrator agent, we're also sending the previous messages. Those previous messages have to be saved somewhere. They're saved inside these .db files. They're SQLite databases. In the next couple of videos, what we're going to do is we're going to set up a Supabase database that will take the place of these SQLite databases. All right, so I hope that makes sense. Let's see what else I have to show you. Okay, remember I was talking in the beginning of this video about the chat.py or the chat underscore agent file, I should say. Whenever we ran this management command, python manage.py chat underscore agent. So all of this code here, 203 lines, I told Claude Code, hey, go look at the OpenAI Agents SDK documentation where all of the rules of how to use the OpenAI Agents SDK are defined, and go write a management command for me. And it knew that it would put the management command inside of the management folder and then inside of the subfolder called commands. And then based on the documentation that I passed to it for how to interact with the OpenAI Agents SDK, it pulled in or it imported certain things like this import runner and import SQLite session. This runner is a core piece of the OpenAI Agents SDK that controls how the entire process works, how the context is passed to the agents, and how the words are streamed in chunk by chunk rather than receiving a whole message at the exact same time. This management command also has these arguments here that we had talked about, where we have the user ID as a flag, the prompt as a flag, show events, and then clear session. So this clear session was actually recently added. You can see here from my Claude Code discussion today, preparing for this video, this clear session clears the conversation memory before starting fresh. So it runs a command that clears the conversation. It clears the SQLite database so that previous messages, like adding an appointment to my calendar at 2:30 p.m., aren't remembered from previous conversations. The AI's brain is effectively blank whenever we clear the session using this clear session flag. So these are arguments that can be added to the chat under agent.py file, which is a management command, which, just to say it again, we run by running python manage.py chat underscore agent. That's telling the Django system, hey, this guy wants to run the code that is defined here inside this file, and he wants to run it with the user ID test user. Or if I wanted to clear the session, I could run it with python manage.py chat_agent user ID and then clear session. And then I can even have that session start with a prompt. So that will clear the session by passing that clear session flag along with the user ID to clear the messages for that user ID. Okay, the only other thing that I want to show you is down here. Let's see. Inside of the management commands, I also have a bunch of different tests. So I like to tell Claude Code whenever I'm using Django as my backend, I like to tell Claude Code to write management commands as tests rather than writing actual test files in the tests directory. Now, a lot of people might disagree with me, but I like running management commands instead of running individual tests. All you have to remember from what I just said is if you use Django and Python as your backend, it makes a lot of sense to have the AI write tests to test what it has done, test the progress that it has done as management commands so that you can easily run those management commands, see what the output is, and pass that output to the AI. Okay, I think that about sums it up. The last thing that we'll do in the next couple videos, I've alluded to this a couple times now, is set up the database. Right now, there isn't any way for us to store previous messages and information about users. And for that, we need our database. If you go all the way back to our very first video introducing Vibecode Camp, we talked about the 3 or 4, but for all intents and purposes of this video, 3 core pieces of our application. We have the front end, which is the application the user interacts with. We have the back end, which is the brain that is a lot of the stuff that I've showed you here today that says when a user receives a message, send it to the orchestrator. And then the orchestrator sends it to those other sub agents. That's the back end, that's the brain. Then the third and arguably the most important piece of this entire system is the database. It's where we save data that we can then load into the back end and then load into the front end. In the next couple videos, we will set up the database using a service called Supabase and use a PostgreSQL specific database. That has been a little bit difficult in the past, but Supabase and PostgreSQL databases are so widely used that thankfully Claude Code knows a whole lot about it. So I think that wraps it up for this video. I hope that everything I said makes sense. I know that there is a lot of new information here. If you decide to set something up like this for yourself, make sure that you pass all of the documentation over and over and over again for the OpenAI Agents SDK and for Composio to Claude Code as you build this process. That was really the breakthrough that I had, was keep passing the documentation and always document your progress in those documentation files like I showed you whenever we came back here after the demo. Okay, let me know if you have any questions, leave a comment, and send me a message if you need anything. Thanks as always for watching. Thanks everybody.